Good afternoon, everyone. Thanks, Patrick, for the introduction. I'm Riccardo. I may suggest by my accent I'm from Italy, from Rome, so not having native English like the colleague before. And in 10, 15 minutes we will talk about data analysis for predictive maintenance. Just to introduce myself, so I'm an architect and just finished a master in philosophy of digital, so I was very interested in the presentation from Nicholas about ethics and people, and I think this is something really focused on digitalization right now, so the role of people and the ethics from data and other aspects. So I'm the owner of a couple of companies dealing with digitalization process. Okay, so BIMon mostly is a consulting firm, so we help other clients, so designers, construction company, in projects, on historical projects, dealing with BIM. We will talk about it a little bit in two phases. The first one starting with the concept for digital twin. So I see something in the presentation before, that's great. So this is something where we start working with the client. We have always to explain, of course. We have to explain already what BIM is. So right now we're talking about digital twin and the data analysis workflow for obtaining predictive maintenance. And the second part, I will show you a case study we worked last year for an historical building in Italy with a focus for energy saving and for predictive maintenance. So starting from digital twin, I took the definition from the Digital Twin Consortium. So, of course, digital twin is a representation of the real-world entities and processes synchronized with a virtual one. So the synchronization and the exchange of data between the physical, the real world, and the virtual one is the main aspect. Is what give a virtual model the fact of being a twin. And of course, is something that use data to represent past and present of a building or infrastructure. And of course, it helps us to simulate and predict the future behavior of the building. So it's something really important, focusing on the data. And it's optimize also the decision from the clients, from the owners, or from the stakeholders, because it's data-driven decisions. So of course, it's something related on data. And of course, it's guided by domain knowledge, so we have to know about real estate in doing this. And the main aspect for me is the action, so the actuator comes from the virtual world. So the main aspect is we simulate, we predict the behavior in a virtual asset, but the information has to come back to the physical one and do something and make an action to make this work. So I see that mostly in Italy, but I think also everywhere there is a little bit of confusion right now, so digital twin. So a lot of people think like BIM model in cloud is something like a digital twin or a digital representation. So basically, in the first case, when we just have a digital model of a physical asset, it's just BIM, so you don't exchange data, you just make a photography of a certain time on a certain type of building and have a digital representation of this. When you go on, so you acquire also the photo, let's say, you acquire also a data flow from the physical aspect, and you can, for example, visualize in cloud with dashboard and others, but you don't give back any information or any action. Then we talk about digital shadow. Okay, so this is something really taking places right now in our industry. This is really important, really useful, but the important aspect is the bidirectional flow. So it's the automation comes from the insight and the decision we make in the virtual aspect. They can be automated or not. So they can be just information we give to the one to take action or automated one. So I bring some example here. Of course, digital twin is something, it could be really different in really different phase of the design of construction, of course, or after construction. So for example, it could be something upon infrastructure that give us information on the use of the bridge and if might collapse, so we can intervene in doing this. It could be something on a city scale. I see some stand around here with some interesting platform upon this, so we can have layers of information about the traffic, the weather, and take action upon this. Also, Google Maps, if you think, is something like a digital twin. Okay, so you get a virtual representation of the city, and you have information. You took action. You take a road instead of another, based on the virtual, of course. And of course, there are all the work basing on security and safety and the post-construction phase of facility and energy. That is the case history is about. So this is the main workflow for us. Try to summarize it in 4 main macro steps. So the first step is starting from data. Okay, starting from data acquisition, so data assessment from the client is the main important one. So starting with the end in mind, focusing on this. I think every presentation before me is focusing on this aspect. So this is the really important things, the things that give value to the process. Mostly when we start in design or construct something, we just start in modeling 3D and do clashes and others. So the really important step is before the form data. Then we have the digitalization, of course. Mostly both for new or existing building. Imagine that Italy has 75–80% of the real estate market is upon existing building. Okay, so we have a lot to do with digitalization on existing assets. And the third step is to integrate the data into data platform. That could be something in cloud, something server. So this is a place where the client can have access to the data in an easy way. So your clients never open Revit and other files. Of course, it's not technical ones, so they have access to the data in an easy and intuitive way, in my opinion. And after that, there is the brain, let's say, of this in order to make the action automated. So there are AI, machine learning models and algorithms to analyze the data and make the decision. So this is fast, just the first part. I show you something we did last year with a client here in Italy. So this is an office building. It's a historical one. It's like 5,000 square meters in northern part of Italy. When the client asks us, okay, I want to make saving in energy and facility, because this is like my home, I want to manage this better in order also to manage better the other building I will have in the next years. And we said, okay, you have data, of course. I have a lot of data everywhere. Our clients, 90%, 99% of the time, doesn't have data or doesn't have structured data. So it's really important to, in my opinion, create a culture upon data and talk with the client, explain to them. For example, this client neither have a BMS system for the MIP in this building, so we have to start with an architectural phase, let's say an infrastructure for the data. So we started with the data assessment, as I said before. So basically we start talking with the people inside the company and the people that are consultants for the client. So the one who perform the energy maintenance and pay the bills for the energy, the other ones, the company who deals with facility management and acquires all the information. So basically they use, sometimes they use software, sometimes they just use Excel or buy paper. So this is a real complex world that I think is different client by client. So this is, I think, it's like 50% of the work on the job was on this phase. So it's very important to create a data structure, validate data structure. And in this case, we also put some IoT sensor for the energy monitoring inside the building for 6 months before starting the next phase. The outcomes, of course, the outputs are graphics, dashboard, when we show the clients what they have, what data we acquired during the assessment, and the interpolation of this. And so basically what we understood upon this and do some case history to follow in the next step. The second step was the digitalization. In this case, it's also interesting, we use autonomous robot. The one you see there is Spot from Boston Dynamics. So there are robots that can go autonomous during the building and acquire geometry information. So with LiDAR and laser scan, they acquire information. And then we use like a point cloud and photos to reconstruct the BIM model. It's a really interesting technology. Also, you can go in the building when after the office time, there was a problem with this, and do inspection by yourself. So it's very interesting, this. And so the second step, as I said before, is the digital model. So the digital asset where you can collect the data. The third step was the data platform. So there is a lot of solution data platform. This client was their own data platform. Okay, so we customize our solutions on this, starting from Autodesk Forge as visualization. We use Autodesk most of all. So of course the title in Italian, sorry. So of course it connect data comes from the asset with external data, so economics, also weather data, all kind of source we have. And in order to make the client easy to visualize it and to manage this, they have 2D and 3D visualization, of course, because a lot of people are not friendly neither with the 3D. And they ask us also to build up some features, for example, the ticket opening for maintenance. So they want a little ticket workflow for open a ticket and manage this. And it was very interesting also because we collect all the IoT sensor for the monitoring. So the guy who before monitoring the energy consumption just by the bills now has real-time data about consuming, and just this make, that's what I said before, the data-driven decision. So the people can visualize the data upon their assets and make better decision based on this. So it will be really interesting just in this part. And of course the dashboard part, so the visualization is really important. This is integration with Microsoft Power BI, so it is common using platform for dashboard. The thing is there are interactive dashboard, of course, so they can isolate certain data and work upon this, and they really appreciate this. The last part was for DI machine learning models. So we starting doing the data assessment, integrate the data we miss, for example, for energy consumption and monitoring. Then we create the digital model and collect everything inside the cloud platform in this case. And then we create some algorithms basing on the needs of the client. In this case, there are two main aspects they wanted to go deeper. One is the consumption forecasting. So we train the model for electricity, gas, water, refrigerator units, so the main aspect of consumption they had. And starting from this, we use that metrics and we starting monitoring the building and starting to predict the behavior of the building. Of course, when, for example, what happens for energy? We can turn off certain equipment if they don't need to use it, or we can buy energy in the period that costs less. I don't know, in other countries, in Italy, for example, in the night the energy costs less than in the morning. Okay, so you can set up this, and you gave a lot of saving upon this. For the maintenance instead, the model is based on the historical data, of course, and there is a building that has 200 years, so there is no structured data, but there's a lot of historical information we get, and the current data sent by IoT sensor and the facility software we ask the client to improve. And so right now we're able to predict the failure of certain systems, so mostly they focus upon certain systems, not everything, of course. And not make an intervention after something were broken, of course, for example, a light, but before it happens. So with a certain amount of accuracy, of course, it will be increasing during time. We're able to predict, okay, do the lighting changing before entering months in order to avoid some problems. So the results was very good in this first year because they had, from their perspective, they have an energy cost reduction up to 20%. There is really, of course, they didn't start in optimized solution, so there's not very good, but it's a great saving, so it works very, very good. Of course, they dedicate also less people to do this because they have an infrastructure, let's say a system to help them doing this, and they have a less problem to solve, so they dedicate time to make better decisions and manage this. And now they ask us to help them with a big hospital. It's a new construction they completed because the construction company wants to manage this way. So I think this is really, really interesting to help the client focusing on the value come from data, help them reaching this value, of course, so extract the value from this, and visualize it in a way they can easily understand, easily interact, not in a just technical software. Otherwise, it's very difficult for a non-technical client, of course. Yeah, and that's it. Thank you.